All right, guys, for this paper, we are going to discuss biology paper 3. We are going to do energy value of food subtopic. All right. So let's get right to it. So you're required to carry out an experiment to determine the energy value of groundnut and bread food samples. Okay, so we have two food samples here, groundnut and bread. Immediately, you must know groundnut has a high lipid content. Okay, bread has a high and also protein. Bread has a high carbohydrate content, right? Okay, state the following for this experiment. What's the manipulated variable? So what are we manipulating here? We got two different types of food sample, right? So manipulated variable will be the type of food sample. Okay, now what is the responding variable? What are we going to get at the end? So in this experiment, what we want to find is the energy value, right? Okay, so the responding variable here is the energy value of the food sample. Okay, so then what is the fixed variable? What don't we change? In this experiment, this is the setup, all right? What we are going to keep constant is, can you see we have distilled water inside here? All right, we have distilled water here. Let me just change all this to English. Thermometer, this is a cotton wool, this is a boiling tube. This is distilled water. Bagi versi bahasa Melayu, saya akan tinggalkan pautan dalam huraian ya. Okay, this is the food sample and this is needle, this is plasticine. All right, so this is the setup. Okay, so you can see we have distilled water inside the boiling tube. So what we are going to keep constant in this experiment is the mass of that water. Right, the mass of water that we use must be fixed. Okay, so now we go on to this part. So this is the setup, right? I hope they will give it to you. I think they would, all right? They will show you this setup. If not, please remember this, right? If this comes out, that is, all right? Plan the experiment using the apparatus and materials provided. Your procedure should include, okay, method to handle variables and precaution steps. All right, now, based on the latest information that I have gathered this year, based on the latest information this year, it seems like the format of procedure, okay, that is required is a mixture of what we did in my previous video for physics and chemistry, all right? So basically what is needed here is you need to write the full procedure, like how I taught you in the chemistry video, right? But the marks are given only based on the variables, how you control the variables, and the precaution step, like how I taught you in the physics video. Okay, now don't worry, we go step by step. All right, so basically what you need to do is, if you can write the full procedure. Okay, if you can write the full procedure, marks are only awarded based on the variables and the precaution steps. However, I cannot confirm whether or not marks will be deducted if you don't give the full procedure. I cannot confirm. I don't have that information, right? If anybody does, please do share with all of us in the comment. All right. Make sure you have reliable resource. All right. Okay. So anyway, let's answer the question based on the latest information available. All right. Okay. So like I taught you in chemistry, basically there are 4 steps to any experiment planning. Okay. Anything. Number 1, we measure and prepare everything. Okay, after you've measured and prepared everything done, start the experiment. Okay, after you start, then you observe or take observe and record. Okay, observe and record the data from the experiment, collect the data. Okay, state your observation, measurement, whatever you're doing at the end. And finally, we would repeat if there is a manipulated variable, that is. Okay, so if it's an experiment, then it's not an activity, then you would change something. So you repeat the experiment and then repeat with the thing that you have changed. Or sometimes you don't need to repeat, because at the same time, you got 2 different test tube or 2 different beaker, 2 different containers of the experiment happening at the same time. So in that case, you don't need to repeat. All right. Okay. So for this case, we do need to repeat. So let's go through this one by one. So what do we need to measure here? What do we need to measure? So number one, look at this setup. Okay. Whenever they give you diagram, this is your best friend. This is your best friend. Look at the diagram. See anything. Are we measuring anything here or not? When before we start the experiment. Remember, this is before. Measure and prepare is before experiment. So before we start the experiment, are we measuring anything? Now, clearly, we need to measure the distilled water and put inside, isn't it? Right? So the first step will be measure 20 ml. Here, it's suitable to use 20 ml. Measure 20 ml distilled water using a measuring cylinder. Please do this just like I taught you in chemistry. All right. You state the instrument. State the instrument that you use to measure. Okay. State the apparatus that you use to measure. So in this case, the measuring cylinder. So measure and pour, just like in chemistry. Measure and pour into a boiling tube. All right. We are using a boiling tube because we're going to heat it up, not a test tube. Right. Boiling tube. Okay. Then what else do we need to measure here? Nothing else to measure lah. Nothing else to measure. Now, this food sample, because of the formula later, you do need the mass. You do need the mass. So the mass, there's two ways this can happen. Either they give you the mass on the label, or you need to weigh yourself. So if the mass is not given on the label and you need to weigh yourself, then you need to write in the procedure. Okay. For my sample procedure, I'm going to assume that the mass is already written down for you. So there's no need to weigh it. Okay. If you weigh, please weigh the mass of the food sample using an electronic balance. Okay, I don't think they'll make you use electronic balance lah. Okay, but I don't know. I don't know. Just be careful. Okay, so measurement all done ready. Next will be the preparation. So what do we have to prepare? Basically, we need to set all these up lah. So you just look at the diagram. That's why I say the diagram is your best friend. Look at the diagram. Just state everything slowly, one by one. What are you going to do? Okay. You already poured the water inside the boiling tube. That's all you did so far, isn't it? What do you need to do? You need to mount it up here. Then you need to put the thermometer, right? After that, you need to put the food on the needle. And then you need to put it on the plasticine and all that. All that just based on this diagram. Very simple. Don't worry. Very simple. It's not difficult. If the diagram is given to you, if the diagram is given to you, don't worry. It's very simple. Look at the diagram, write everything down. So what else we need to prepare? Okay, let's write it down. So first we need to clamp the boiling tube to a retort stand. Okay, because the boiling tube can't float, isn't it? Okay, we need to clamp to a retort stand. Okay. After that, what do? Put the thermometer. So we say we fix the position of the thermometer using a cotton wool. Of course, this one we will also be using a clamp. Okay, don't clamp too tightly, it will break, right? So clamp the thermometer and then place it, fix the position using a cotton wool. This is what we use to explain this action, right? So after this thermometer is done, what else? We need to settle the bottom part, the food sample, the needle, and the plasticine. Okay, so now before we do that, at this point, after you put the thermometer, you can already start taking measurement lah. Okay, so according to the textbook, this is the order, but actually you can set up everything first and then measure. Okay, I tell you what, I don't want to confuse you. Let's set up everything first. Okay, so then you poke the ground nut onto the mounting needle. Okay, poke the ground nut onto the mounting needle here, this needle, and then keep it upright using the plasticine. Okay, in one sentence, we have already finished the explanation of the preparation at the bottom. Done. Okay, all right. Now, then after that, we are going to place a wind barrier around the apparatus setup. The wind barrier, you know the wind barrier. It's a large sheet of metal, usually aluminium. Right. So it's a large sheet of metal to block the wind. All right. Wind barrier. Okay. So now, why is this bolded? Because this is also the precautionary step. This is also so you can see the precautionary step is within the procedure itself. It's not separate. It's within the procedure. So this is one of the precautionary steps that you can use. You will get 1 mark for this. Okay. All right. So after you set up everything ready, all done ready, now we can start the experiment. Okay. However, before you start the experiment, okay, there's one thing that we need to do here. Now, I hope you have studied up your theory here. I will talk more about this formula later. However, I just want to point out you need the increase in water temperature. If you need the increase in water temperature, you need two temperatures. You need the initial temperature and then you need the highest temperature. This is another thing I'll explain later. Anyway, initial temperature is required. So here you must state, this is the point where you measure the temperature, right? Okay, this is where you measure temperature. So measure the initial temperature of the distilled water. Once again, please state using a thermometer. Always state what is the apparatus that you use for your measurement. All right. Okay. So now we've already measured and prepared everything already, all done already. Measure and prepare done. Okay. First step of the experiment done. Finish. Okay. So let's get rid of it. So the next step will be to start the experiment. How do you begin this experiment? The experiment starts when you burn the food sample, right? So that's all you have to explain. So what are you going to explain? Light the groundnut. How are you going to burn it? You're going to light it using a matchstick. Okay, I have stated matchstick here. Depends on what apparatus you receive. Maybe you're going to get a candle. Maybe you're going to get a Bunsen burner. I don't know. Okay, so please be careful here. Use whatever is given to you. If it's a match, then you write match. Okay, and then place it below the boiling tube. Okay, done. We already started the experiment. Finish. Settle. Start. Ready. Okay. After you start the experiment, what's the next step? Now you need to start collecting your data, isn't it? Observe and record. You must always state observe and record. So observe here does not necessarily mean just an observation. Observe here, the observation could be a measurement. Okay, so if that's the case, then it will be measure and record. Measure and record. Okay, data collection time. All right. So what do you do next? What do you know next? We are going to measure the highest temperature. Okay, we are going to measure the highest temperature using a thermometer again, of course. Okay, measure the highest thermometer using highest temperature using a thermometer. Please don't say final temperature. Final temperature is not accurate here. Okay, measure the highest temperature. Okay, of the distilled water using a thermometer. Now, this is correct. We have another precautionary step here. Okay, that precautionary step is after the groundnut has completely burned. This is another precautionary step. Okay, this is important. That means you have to wait until everything is completely burned ready. It's already completely burned, gone. Then only you take the highest reading. All right. Okay, so observe, record. Anything else we are going to observe? Nothing. We already measure. We already measure and the highest temperature. What's the next step? Record. Please do not forget to write record. Please do not forget to write record. All right. Okay. Okay. So let me just double check. Okay. Okay, class. Sorry. Here also same case. When you measure the initial temperature, please don't forget to write record. Okay. So you can say measure and record. Or I like to put it in a separate line here. Measure and record. Measure and record. Every time you measure, you record. Okay. Every time you measure, you record. Please don't forget that. Okay. Measure and record. Done. All right. So both times the temperatures, measure and record. Every time you say record, please say in a table. This is also important. Okay. We record all the data in a table. Right. Okay. So observe all the observation and the recording is all done, completed already. So already finished. Done. Nothing else to measure, record, isn't it? Okay. So what do we do next? What do we do next? Repeat. Now, before we repeat, okay, there's a special step here because we want to find energy value. But energy value we cannot observe. Okay, energy value we have to calculate, isn't it? Right? So then after you finish taking all your readings, then your next step is to calculate. Calculate. So you write in your procedure, calculate the energy value using this formula. Now, this formula should be given to you. Should be given to you. I will explain how to use the formula later in calculation. Okay. So calculate the energy value using this formula. Done. Last step will be to repeat. Okay. So now we are going to repeat the whole thing. So you repeat steps 1, 2, 11 here by replacing, what are we replacing? Replacing the groundnut with bread. Finish. Done. Okay. So writing the procedure, guys, writing the procedure is not that difficult a task. Don't worry. Don't worry. It's not very difficult. Just follow the steps. You measure and prepare everything first. Start the experiment. Collect your data. Make sure you use measure and record or observe and record, whichever it is lah. Okay, whatever you are doing at the end, and then finally repeat. Repeat sometimes may not be necessary, as I explained just now. Okay, so that's it. That's it. Don't worry. Diagram is your best friend. Use it. Use it. Okay. All right. So procedure part is done. So tabulate your data. So how to tabulate this data? So very simple. This one is very simple. We got your MV and your RV. That's it. But your RV here, you must be careful because the RV is calculation. What do we get from the data? We don't get the energy value from the experiment. The data that we collect is not energy value. That one we calculate. What do we collect? Initial temperature, highest temperature. Okay, so that's why just now it's important. Measure and record in a table. Measure and record in a table. Okay, so what will the table have? Whatever we recorded, this one, right? So you have an initial temperature. This one, of course, you fill in whatever values you got in the experiment itself. All right. So initial temperature, highest temperature, done. Okay, after you fill that, finish. Table is very simple here. Okay, state one observation in the experiment. Okay. Now, just like chemistry, your observation must be really something that you observe or you measure during the experiment, right? So very simple. What do we observe or measure here? The temperatures, right? Initial and highest temperature, right? So don't do any comparison here. Okay, once again, I'm basing this on the latest information that we have. Latest information that we have. Do not do any comparison here. You just say for the groundnut, initial temperature is this, highest temperature is this. Or you can say for the bread, initial temperature is this, final temperature is this. Okay, all right. So that's exactly what we are going to say. For the groundnut, the initial temperature is P degrees Celsius, highest temperature is Q degrees Celsius. And then what is the inference for this? Inference here, once again, is the explanation. This one is just like chemistry, not like physics. Not like physics. Okay, inference is just explaining the observation. All right. So state the inference. What is the inference? Why is it like that? Okay, why is it like that? That's because hold on. Okay, so why is the energy value like that? That's because the groundnut contains lipid. Okay, the groundnut contains lipid and releases a large amount of heat when burnt. Okay, this is important. Releases a large amount of heat when burnt. So it shows a high energy value. Okay, all right. It shows a high energy value because actually what I'm doing here is in this answer, actually I've added some insurance. So actually just based on this, why is the initial temperature like this, higher temperature like this? It contains lipid and releases large amount of heat. All right. This should be it. But just for insurance, we talk about the energy value as well, which shows a high energy value. Please include everything. Include everything. Okay. Better to have insurance. Right. Okay. Done. Okay. So state the hypothesis. So hypothesis again, guys, same format. Same format for all the sciences. So here, usually we use when MV increases, decreases. Okay. Usually we use when MV increases, decreases, RV increases, decreases. Now, I told you in the previous videos, this can only be used if the variables are quantitative. They have values. Now, our MV is type of food sample. Does it have any value? No, food sample, groundnut and bread. How are we going to say when the food sample increases or decreases? Cannot, isn't it? So in this case, we cannot use this format. So what do we use instead? We use the concluding statement. Use the conclusion for the experiment as the hypothesis. So at the end, what are we going to compare? We're going to compare the energy values, right? So what is the hypothesis? Which one will be higher? Okay, which one will be higher? The energy value for groundnut is higher. right? Because it contains lipid lah. Lipid will give a higher, release a higher energy, release more energy when burned compared to carbohydrate. Okay, so in this case, the energy value of the groundnut is higher than the energy value of the bread. Okay, that's the hypothesis. Okay, now let me explain this calculation to you. So this is the formula, like I said, should be given to you, should be lah. Okay, but anyway, it's not too difficult to memorize. So you learn your physics, this one. What we have is mc delta theta. So this is actually Q. This is actually Q. mc delta theta divided by the mass of food sample in grams. Why divide by mass of food sample? Because we want per gram of food. Okay. And why do we divide by 1000? Because we want to convert the joules into kilojoules. Basically, that's it. mc delta theta over 1000 mass of food. Finish. Right? So, but I don't, okay, I don't want to say anything. Okay, so that's it lah. That's it. So let me teach you how to use this. So energy value of, so first we do the groundnut. So energy value of groundnut, what is the mass of water? Now, please don't get confused. There's two masses here. This up here is the mass of water, not the food sample. Food sample mass is at the bottom here. Right? Food sample mass is at the bottom. Okay, so what is the mass of water? This will depend on, okay, you have to check in case they give you procedure, check the volume of water used. All right. So here we take 1 ml is 1 gram. 1 ml, 1 gram. So 20 ml means 20 gram. Now you have to be careful and use whatever mass is given to you. If it's given, if you have to write the procedure yourself, you can use this, no problem. Okay. But if procedure is given to you, please check the mass of water. Okay. So according to my sample answer here, okay, according to this sample answer, then the mass of water is 20 grams. Okay, so 20 grams times 4.2, this one is fixed. This is the specific heat capacity of water. All right, times Q minus P. Okay, they want the increase in temperature, right? So you take the highest temperature minus the initial temperature based on your data here. Based on your data here. This one minus this one. Okay, so that will be the increase in temperature. This is the change in temperature, delta theta, over X gram. So X gram will be the mass of the groundnut, which will hopefully be labeled for you, or you would have measured yourself using the electronic balance. Okay, make sure it's in gram. Please make sure it's in gram. Okay, and then times 1000 at the denominator. So you will get your answer. Answer will be in kilojoule per gram. Please be careful of the units. So how do you do energy value for the bread? Same case. Same case. Just use this. And then you use S minus R. Use your data again. Use your own data. S minus R. Highest temperature minus the initial temperature. And then this one again, check the mass of water that you're using from the procedure. Okay, 1 ml is 1 gram. And then this is the mass of the food sample. So that means we have Y grams of bread. Okay, and then times 1000, let it change to kilojoule. Done. All right. Okay. Okay, now draw a graph to show the energy value of food sample. Draw a graph. So how do we draw a graph here? Once again, you have to be aware our MV is qualitative, right? It's not quantitative. There's no quantity. Type of food sample got no quantity. So what kind of graph can you get? You are not going to get a line graph here. Okay. Since there's no numerical value, what we will get is bar chart. You'll get a bar chart. So write the title of the graph first. Graph of energy value against type of food sample. Yes, please always include the topic of the title of the graph. Okay. Okay, now we can draw the graph. So the graph, we have this. Okay, use your own value, of course. Use your own value. Use your own value. This will be in a graph paper. So you have to mark your own value. What value is this? What value? You have a scale here. You will have a scale here. Do your scale properly. This one and this one. Okay, do the scale, the whole scale. Don't just mark this. Draw the whole scale on the y-axis. Okay. X-axis is just groundnut bread. That's all. Finish. All right. So this is how your graph will look like. if they ask for graph. Okay, now the experiment is repeated using a coconut kernel. Predict the energy value. Predict the energy value obtained. Okay, so when we use coconut kernel for this experiment, that means when you burn the coconut kernel, what kind of energy value you get? The answer is it will be higher than the groundnut and the bread. It will be higher than the groundnut and the bread. Okay. All right. Explain your answer. Why? That's because the coconut kernel has a high lipid content. Right? Coconut, high lipid content. And so it will release more heat energy when completely burnt. This is important. This is important. It releases more heat energy when completely burnt compared to the groundnut and the bread. Done. All right. Okay, class. So okay, guys. So I think this is it. This is all I've prepared for you. All the best. All the very best to you. I really hope this one comes out. Please read the question carefully. All right. Procedure. Remember what I taught you. Okay. Any other resources you need? If you need more resources, you want to get more classes and all that, you can go to mrrueltuition.com. Okay, guys. All the best. All the best.